If you're looking for one video to learn TypeScript, you have come to the right place, as in this course, that's exactly what I'm going to do. I'm going to explain the fundamentals of TypeScript, as this is going to be a collection of individual videos that exist here on my YouTube channel, but they're all kind of compiled into this one single video, so you can learn the fundamentals all in one place. So some of the transitions between videos might not look totally seamless, but I think that you'll forgive me on that one. So without further ado, enjoy this TypeScript course. I definitely think if you make it to the end, you're going to learn a ton about TypeScript and actually be able to use it in your own applications. What is TypeScript? What are the benefits of it? And should you learn it and should you use it within your programs? Well, TypeScript, it's JavaScript, but it's JavaScript with added syntax for types. JavaScript does have a type system, and values in JavaScript, they do have data types. Things like strings, booleans, numbers, things like that. But in JavaScript, the type system just dynamically knows those types, and it will dynamically assign those types to values. You don't need to explicitly say this value has this type in JavaScript. So for example, on line 15 right here, I have a constant called number, and I assign it to the value of 12, which is a number. And if I use the type of operator and I check, okay, what's the type of this number here? Well, in JavaScript, I'm still going to get number here. All right, so JavaScript, it definitely does have types within its program. But in TypeScript, you can explicitly give a value a type. So here on line 24, this is TypeScript code, and this is what this would look like. So here, I have a constant called my number, and I use colon, and then I say number after that colon. So what I'm doing here, and you don't need to know the syntax right now. I will have future videos on how TypeScript works in a little bit more depth, but I'm basically saying with this colon here that this variable here, this constant, it is going to be assigned the type of number. So this constant is going to hold a value that has the data type of number, and I assign it to the value of 12. But if I try to assign it to a string here, you see that I get an error. It's saying, hey, type string is not assignable to type number. So TypeScript will catch these errors because I need to explicitly say what data type a value is going to have here. So I can use the value of 12. And then here on line 25, I have a constant called greeting, and I'm assigning the data type of string with my colon here to whatever value that this greeting constant holds. And I put hello in there. But you can see if I try to change this to a number, I'm going to get an error because I'm trying to assign a number to the data type of string. So in TypeScript, you can explicitly say what data type a value is going to be. And if I use the type of operator here, you're still going to get what you would expect here. So if I run this here, you're going to see I get number and string. All right, so those data types all align. Now, one thing to note is that in TypeScript, you don't always need to explicitly give a type to a value. TypeScript has something called type inference, to where I can remove this altogether, and TypeScript already knows it is going to have the data type of a number because I'm assigning a number to it. So TypeScript will already enforce the type number to this constant. Now, since this is a constant, it can only be this one single number here. But if I change this to a let, then TypeScript would let me change this my number variable to any number I want, but it would still have to be data type of number. So TypeScript does have type inference, in which you don't need to always explicitly give something types, but I'll cover that in future videos a little bit more. Now, this is also going to work for functions here. So on line 30, I define a function called add. It takes two parameters here, num1 and num2, as you can see right here. And what I do is I use the colon, or the data type assignment operator here, and I assign the data type of number to num1, and I do the same thing for num2. And here, after my parentheses here, I use colon number, and that's going to say I'm going to return a number from this function. And then what I do is I return num1 plus num2. So if I run this code here, and I call my add function, I console log the result, you're going to see I get exactly what you would expect. I get 3. But what happens if I try to pass a string to this function? Well, TypeScript is going to yell at me right away. It's going to say, hey, argument of type string is not assignable to the parameter of type number. So if I try to add a string and a number, I'm not going to get the result I want, and I'm probably going to get a bug in my program. So TypeScript helps prevent this by just saying, hey, what you're trying to do here doesn't make sense. This doesn't align with the function definition that you gave here. So in TypeScript, you can explicitly give values different data types. To where JavaScript, it just kind of implicitly knows the data types. Now, TypeScript does have type inference, in which you don't need to always explicitly give something a data type, but TypeScript will still enforce those types to those different values, even if it is an implicit data type. One thing that's important to remember is that it will compile down to JavaScript. So TypeScript, it will get turned into JavaScript. So all of these type definitions here, those are going to be removed. And when this gets compiled and run, it's just going to be JavaScript code, which means that TypeScript can run anywhere that JavaScript can run, which means that you can use TypeScript anywhere you use JavaScript. Now, what are the benefits of TypeScript? Well, I think one big benefit of TypeScript is that it gives you a better understanding of your code. If you have to explicitly give different values in your code certain types, then you really have to know what's going on in your code, and you have to know the potential values that are being assigned to different variables and the potential data types of those values. And you have to think through your code a little bit more, which I think is beneficial, and TypeScript forces you to do that. Also, your code editor is likely going to have a little bit better autocomplete if you are constantly defining your types, because it's always going to know like the interface or the structure of a certain value, and it's going to be able to provide better autocomplete because of that, which I definitely think is a benefit as well. Now, I would say potentially the biggest benefit of TypeScript is that it allows you to catch certain bugs or certain errors at compile time instead of at runtime. So for example, when I tried to do this with this function here, in which in my function definition, I assign my parameters to numbers, but when I called my function, I tried to call it with a string here. I don't need to run this function to know that I have an error here. TypeScript already knows, hey, what are you doing? You're trying to pass a string to a number parameter here. And it tells me right in my code editor, this is VS Code here. So at compile time, this is already giving me an error and I can fix it right away. But in JavaScript, I wouldn't have this error here. I would have to run this program and I would have to run this function to eventually see that I'm adding a number to a string, so I'm getting this like weird coercion to take place, and I'm just getting an incorrect value, and that's going to take more time rather than seeing this right away. So TypeScript can allow you to catch these errors right away when you are writing your code compared to when you are running your code, which can speed up development, and I think is one of the biggest benefits of TypeScript. And then also it can also be self-documenting to where, if some other programmer wrote this function, I know exactly how I need to call this function. I need to call this function with two numbers. I should not call this function with any other data types. It can be self-documenting and allow for better understanding across a development team. And in my experience, TypeScript, it can take longer to write up front. So when you're first learning TypeScript, it's probably going to take longer to write compared to JavaScript, which some see as a detriment. But I think that over the long run, TypeScript ends up speeding up development because you're catching these errors at compile time. You probably have to write a little bit less tests with TypeScript. You have a little bit better autocomplete. If your code is more maintainable because it's self-documenting, that's going to lead to faster development over time, especially when you need to refactor things and different things like that. So I think up front, TypeScript does have that cost of it just takes more to define these types and go through all that structure. But I think over time, TypeScript can actually speed up development. And I would also say that a lot of jobs these days and professional jobs are going the TypeScript route when they're starting a new project or they're converting their code base to TypeScript. And I think when it comes to getting a job, it definitely is a nice little bonus if you can put on there that, hey, I know TypeScript. Now, that doesn't mean that there aren't detriments to TypeScript and that TypeScript is all good. Like, it does take longer to write. It can be a headache to try to convert a code base to TypeScript, even if you do it incrementally. Also, there's more configuration of your project when it comes to using TypeScript and the compiler you're using, and there's more complexity to that. Also, TypeScript isn't necessarily just some super easy language to know. Like, yes, it is just kind of a superset of JavaScript, but TypeScript can get complex when you get into some different things that you can do with generics and type aliasing and different things like that. And not every developer on your team might be well versed in TypeScript, and it might significantly slow down your development time up front. And if you're working for a startup and you need to be nimble and move quickly, maybe TypeScript isn't the best option for you. So it's not all just like sunshine and rainbows. But for my personal opinion on TypeScript, I am a fan of TypeScript. And whenever I start a personal project from scratch, I use it. But like I said here, that doesn't mean it's always the best. And there are situations in which you might not decide to use it. The professional code base that I work on is a startup. It's all JavaScript. We don't think it's the best idea for us right now to convert our entire code base to TypeScript when we haven't even reached like product market fit with our product yet. And we're still kind of in the early stages of that. We think it's best to just work on making our application something people would want to use. And then over time, as our company grows and as our team grows, we can make that conversion if we think it makes the most sense. But the big question for you is, should you learn it? And I think so, but maybe not necessarily right up front. And just know that it's not necessarily super easy, like I mentioned earlier. Like there are TypeScript specific things that you're going to have to learn, and it will take time. And my recommendation is I would still learn kind of the fundamentals first of CSS, HTML, JavaScript. And this is assuming you want to be a web or application developer. I would learn HTML, CSS, JavaScript first, and then I would probably pick one framework. I'm a fan of React. And then after you have like the fundamentals of those, then I would start kind of learning TypeScript and learn the fundamentals of TypeScript. And then for your job, if it's written in TypeScript, well, then at that point, you can learn a little bit more on the go and some more advanced use cases of TypeScript. But I would still learn kind of these big four first: HTML, CSS, JavaScript, and then one front-end framework. That's going to get you a job. And then I think that you can learn TypeScript kind of on the go a little bit more. But if you have a good understanding of those and you want to kind of up your game a bit, I think the next best thing to learn might be just like the fundamentals of TypeScript. All right. So hopefully this video gives you a good idea of kind of what TypeScript is, how it works, the benefits of it, and whether you should learn it or not. So thanks for tuning into this, and I'll see you in that next one. Today's video, you're going to learn everything you need to know about type inference in TypeScript. So type inference is exactly what it sounds like. TypeScript will infer the type of some value, and it will enforce that type without you needing to explicitly give that value a type annotation. So you don't need to say that this value is going to be of type number or of type string. TypeScript will already infer that some value has some type, and it will enforce that type. So what does this actually look like? Well, here on line 18, I define a let variable called SumVar, and I assign it to the value of 12. And then on line 19, I have SumVar, and I try to reassign it to a string of hey. And TypeScript is not okay with this. TypeScript is telling me that, hey, type string is not assignable to type number. Well, what's going on here? Well, this is where type inference comes in. TypeScript is inferring that whatever value that is contained within SumVar here, it is of type number. Even though I don't explicitly give this a type annotation here of number, TypeScript is already going to infer, since I am initializing this variable with a number, that SumVar here, this is going to hold a value that is of type number. And it's not going to let me reassign this to a string because it is going to enforce that this is a number here. Now, if I switch this to a string here, then it's going to be totally cool. It's going to say, okay, well, since I'm initializing with this a string, then SumVar should hold a value that is of type string. And if I reassign it to a string, that is totally fine, because SumVar here, as you can see in my code editor, it is annotated with a string. Even if I don't explicitly give it the string annotation, TypeScript will just infer that this is a string, and it will enforce that type to this variable here. Now, where does TypeScript use this type inference? Well, like I just showed you, when you initialize a variable, it will use type inference to say that, okay, if I'm initializing this variable with a number, then that variable must be of type number, or that value is of type number, or if it's of type string, or whatever it might be. However, if I don't initialize a variable with any value, then TypeScript doesn't have any information to give this a type. And it's actually just going to give it a type of any. So as you can see here, it's giving it the annotation of any. And generally, I would avoid any's as much as possible because that's just like running JavaScript in your program and removes the benefit of using TypeScript and those type safe features that you get with TypeScript. All right, so if I just initialize a variable without a value, TypeScript can't do its type inference. But as soon as I give this a value here, TypeScript will infer that this value is the type of the value that I assign it to when I first initialized it. And since JavaScript has an underlying type system, although it's dynamic, it's not static like TypeScript, TypeScript can still leverage that system and say that, okay, well, this is going to be a number. So we are just going to infer that whatever value is contained within some var, that should be a number as well. Now it also uses type inference when you set default parameters for numbers. So here on line 26 here, I have a function called add. And in my parameters here, I have a parameter of num and a parameter of num2. And I give those a default value of 1 and a default value of 2. And if I hover over num here, you can see TypeScript gives it an annotation of number. Because since I initialized this parameter with a default value, TypeScript knows, or TypeScript is going to infer that this parameter should be of type number. And it does the same thing for my second parameter here. So if I try to call my add function with a string here, you're going to see that I get an error. I cannot assign type string to a parameter of type number here. Because even though I don't explicitly give this an annotation of type number, which I can still do this, but even if I don't and I give it a default value here, TypeScript is going to infer that this should be a number, and it is going to enforce it by giving me an error if I try to pass an argument that is anything apart from type number. So it will infer the parameters here when you give them a default value. Now it will also infer the return type of a function. So the way that you give a type annotation for the return type of a function is right after your opening and closing parentheses, you can use the annotation symbol here, the colon, and then I could say that this function here is going to return a number. However, TypeScript will already make this inference in which when I call this function, it's going to say, okay, this return value here is going to be inferred to be of type number, as you can see here. Because TypeScript's going to be like, all right, well, this parameter is a number, this parameter is a number. So if I return this parameter plus this parameter, well, that's going to just give me a number. So it's going to infer the return type of this function to be of type number. And the same would be true if my parameters were strings and I returned a string. And in my return value here, if I tried to give this a type annotation of type string, you're going to see that I get an error here. It's going to say type number is not assignable to type string because it's inferring that the return value of this function is going to be of type number. And it's going to say that I can't assign that to a type string because this return value here is inferred. But if I switch this to a number here, everything's going to be just fine. All right. So three of the most common places you're going to see type inference occur is when you initialize a variable with some value. That initialized variable is going to be inferred to have the data type of whatever value you are assigning to that variable. Also with default parameters, you're going to see it in which whatever data type you give as a default value, that's going to be inferred to be the type of that parameter. And then also the return value of a function is going to be inferred with whatever data type that you return here. All right. And overall, I would use type inference pretty much wherever you can. There are some situations in which I think it might be explicitly better to state what a data type is going to be. Like sometimes for a return value of a function, I think that it would make sense to explicitly say that, hey, this is supposed to be of type number. And one of the reasons that I like doing that sometimes is that it gives you kind of the error here when you're defining your function. Like if you're expecting it to return a number and you just try to return a string here, well, in the return statement, it's going to say, okay, you're doing something wrong here. Not all possible data types here of your return value are of type and number. So it can kind of catch those errors as I'm writing my functions, because if I remove this, I'm not going to get an error here. it's just going to say, okay, well, I'm going to return a string because I'm guessing that's what you want to return. But, you know, in an add function, that might not be the case. And then this gets inferred to be a string. And then like here, you see, I don't really get any errors here, even though I'm returning a string, and that's probably not what I want to do. All right. So for the return values of functions, I do kind of like to explicitly give a type annotation, but everywhere else, I like to use TypeScript's inference system because I think it just leads to a little bit easier to read code, a little bit less messy code, and is pretty straightforward to understand as well. So hopefully this gives you a good understanding of how type inference works, where it's used in TypeScript, and maybe some situations in which I would and wouldn't use it. So thanks for tuning into this, and I'll see you in that next. Today's video, you're going to learn everything you need to know about type annotations in TypeScript. And we're also going to cover the basic types in TypeScript and how to give different values type annotations. And then I'm also going to touch on one thing here at the end that is going to be really important for you to know when writing your TypeScript code. So first off, a type annotation is where you explicitly give some value a type within TypeScript. So it's where you would explicitly say that, okay, this variable is going to hold a value that contains this type. All right. So let me show you how you do this for some various types. So here on line 9, I declare a constant called number. And then as you can see here, after my number label, I use a colon. And this is going to be used to give something a type annotation. And then following that colon, I'm going to use the keyword number. So what I'm saying here is that this constant called the number is going to contain a value that is of type number. And to explicitly say that, I use this annotation right here. I use colon number. And as you can see, then I have my assignment operator and I assign the value of 10 to my num. And then when I hover over my number here, VS Code is going to tell me the type annotation here. It's going to say num is colon number. So this is a number type. And if I try to assign any other data type to this num here, I'm going to get an error. So if I try to do some string here, you see I get the red squiggly under my num because it says type string is not assignable to type number. So here I'm explicitly saying that this variable needs to contain a value that is of type number. And if I don't use a number here for my assignment operator, I'm going to get an error. And even if I try to reassign this num to a string here, I'm still going to get an error because this is going to have to be a number for any value that it holds. But since I used a let declaration here, and if I try to reassign it to another number, that's going to be totally fine. All right, so that is how you do a number type annotation. Now you can do a very similar thing for a big int. Right here I have a constant called big int, and then I use my colon big int keyword for my type annotation. I'm saying this variable is going to contain a value that holds a big int, and then I assign that to a big int here. And if I tried to assign this to anything other than a big int, I would get an error. And then the same thing can be done for strings. I say const channel colon string. So channel is going to hold the value that is a string, and I assign that to code Ryan. And if I tried to assign that to any other data type, I'm going to get an error. And then you can do the same thing for Booleans here. So I have a constant called show modal, and I use colon Boolean saying this variable is going to contain a value that is a true false value, a Boolean, and then I assign that to false. But if I try to assign that to the string false, I get an error because that is no longer type Boolean here. Now arrays are a little bit more tricky for type annotations, as there's kind of a couple different ways that you can do it. You can use a generic syntax, which I will touch on generics in future videos, or you can just use a bit different syntax that I personally find a little bit more readable, but it can be up to you on what you like better. So one way to do this is here on line 22, I have const array1, and I use colon, and then right here I say number, and then a opening and closing pair of square brackets, which this is also how you create an array literal using the opening and closing square brackets. So what this is saying is that array1 here, it's going to hold a array that contains numbers. So this is a number array data type that this array is going to hold. And as you can see, I assign it to an array that contains numbers. But if I try to add any non-numbers to this array, you see that I get an error. I'm trying to assign a string to type number because this needs to be a number array. Now with this, I could also do a string array here. And then if I got rid of all of my numbers, that is totally fine. Or I could also do a Boolean array, and I could change this to the value of true, and that's totally fine as well. But what if you want an array to contain multiple data types? Well, the way that you could do this is I could wrap a pair of parentheses around this Boolean here, and then I could use the OR operator. So this is going to be a Boolean or number array. So now if I add a number to this array, like that, you see that I don't get any errors because this array contains Booleans or numbers. But if I try to add a string here to this array, you see that I get an error. Type string is not assignable to type number or Boolean. And you could use this OR operator for other variables as well. If you know that some variable within your program is going to be either type A or type B, you could use the OR operator. But if the types get much more complex than just a couple of types, then it's probably best to use something called type aliasing, which I'll cover in future videos. So this is one way to use a type annotation for your arrays, but you can also use the generic syntax, which is what I do in line 24. So whenever you see these opening and closing kind of pointer brackets, I'm not really sure what these are called, that is kind of the generic syntax. So what I'm saying here is array2 is going to be of data type. Well, it's going to be an array. So you can use the capital A array keyword here. And then you can open a pair of left and right brackets. I think that makes a little bit more sense. And then I can put what data type is going to be within this array. So this is going to be an array that contains strings, which is what I assign it to here. But if it was an array that contains numbers here, I get an error. But you could also use the OR operator and say, hey, this is actually going to be an array that contains numbers or strings. And then you can see that that compiles because these strings here are either numbers or strings. All right, so those are two ways to use type annotations for arrays. Personally, I kind of like this syntax better, but I can also see how people might prefer this right here. All right. Now, TypeScript also allows you to use type annotations for null and undefined here, as you can see. So I'm saying const n : null, and I assign it to null. But if I try to assign that to a string, I get an error because a string is not assignable to type null. And then the same thing for undefined. U : undefined equals undefined. But if I try to assign that to a string here, I get an error because I can't assign a string undefined to the value of undefined. And then the last type annotation we'll cover in this video is for the function return value as well as function parameters. So you can give function parameters type annotations, just how I give any of my kind of declarations here, type annotations. So within my parameters, I can use colon and then whatever the data type is for that. So I'm saying this function here is going to have two parameters, A and B, and those are going to be of type number. So I'm expecting this function to be passed two numbers here. And then this could be any data type that I use above. It could be null, undefined, string, Boolean, whatever you might want to pass to your function. And following the parentheses, I use colon number. And that's saying this function is going to return a number. So to specify the return value of a function, following your parentheses, you can use a colon and then give it a type annotation. Just like you gave all these variables type annotations, following the parentheses, you can give the return value of your function a type annotation. So I'm saying this function returns a number. And right now, everything works because I'm returning A plus B, and TypeScript knows that since A and B are both numbers, well, if I return A plus B, it's going to be a number. But if I change this to a string, TypeScript's going to be mad at me because it's like, hey, you're clearly returning a number here because A and B are numbers, but you're saying that this function returns a string. I think you have something wrong here. And it says number is not assignable to type string. But if I just returned a string here, it's going to compile because I do indeed return a string. All right. Now, one thing that's important to remember is that you don't always need to use type annotations because TypeScript has something called type inference. And that was my very last video on TypeScript. So I definitely recommend checking that out for a full explanation. But in certain situations, TypeScript is going to know what the data type of a value is, and you don't need to explicitly say it. So here on line 41, I declare a variable called number and I assign that to 12. And TypeScript already knows, it already infers that since I'm initializing this variable with a number here, it's going to just infer that, okay, this is going to be of type number. And if I try to reassign number here to a string, it's not going to work because TypeScript's going to infer that this is supposed to be a number. It's going to say type string is not assignable to type number. So if you initialize a variable and assign it to a certain value, TypeScript's automatically going to infer that that variable is going to contain the data type of whatever value you assign it to. And it will do the same thing if I use like default values. So if I give a default value to the value b here as 1, it's going to infer that within this function definition, since I already initialized this parameter with a value, it's going to assume that this is going to be of type number, as you can see in the kind of type annotation code hint above. All right, so TypeScript can infer the type of a variable and can infer your types in various situations. And I would ultimately use type inference basically wherever you can. Sometimes I do like to specify the return value of a function because that can avoid some errors, which I cover in my type inference video. But for the most part, I would let TypeScript just kind of infer where you can because it makes your code a little bit more readable and you don't have all these type annotations kind of floating around everywhere. But there are going to be specific situations in which you need to use a type annotation and you need to say that this variable is assignable to these different types of values. So you definitely still need to know type annotations within your programs. All right. So coming soon, we'll cover type inference, type aliasing, never, void, unknown, enum. All those are coming in future videos. This was just kind of a video on the basic types in TypeScript and how to use type annotations and what those are as well. So thanks for tuning in and I'll see you in that next. Today's video, you're going to learn everything you need to know about void in TypeScript. You're going to learn where you might want to use this and also where it wouldn't really make sense to use this. So first off, what is void? Well, void represents the absence of not having a type at all. And you will commonly see this where a function doesn't return any value whatsoever. So in a function, if it doesn't return a value, well then, since there is no return value, then there's also no type. So there's an absence of a type. So in this instance, void makes sense because it is the absence of a type because there is an absence of a value. So here on line 10, you can see I have a function called returns nothing. And when I hover over this function, you see that the annotation that TypeScript gives me here is :void, telling me that this is a function called returns nothing and it returns void. And that is because the function, it quite frankly returns nothing. There is an absence of a type here within this function. And if you do have a function like this that returns nothing, I think that for the sake of code clarity and just being a little bit more explicit about your code, in these instances, it might be a good idea to add this void annotation as the return value of this function. So behind the parentheses here, adding :void is saying that this is a function that returns void. And I think that one benefit of that is making your code more clear. Like you explicitly want this function to return nothing. This didn't happen by accident. As in your programs, most of your functions are you're probably going to want to return something. So when you don't do that, you might not want another developer to like wonder, okay, did they mean to write this function to just return nothing? And if they see this :void, well, that's explicitly saying, okay, well, if they authored this to be :void here and gave it the annotation of void, then they likely do want this to just return nothing. So I think it can make your code a little bit more explicit in that standpoint, which can be good for readability and clarity. Now, it probably doesn't make sense to use void when you're declaring a variable and you're just declaring it to a non-value, so null or undefined. As if you declare something to have a void type, so here on line 27, I'm saying some var is of type void. Well, the only two values that I can assign to a void type are null and undefined, because that's how you represent an absence of a value. And since void represents the absence of a type, it makes sense in those situations. So here I can assign it to null, and then I can assign it to undefined without any errors. But anytime I try to assign this to a number like I do here, I'm going to get number is not assignable to type void. Or if I had a string here, the string 12, I'm going to get the same thing here. And the reason why I wouldn't probably use void in this situation is because you could just say that this value is going to be of type null, or it's going to be of type undefined. And I think that would probably make a little bit more sense rather than saying it's type void and then assigning it to either null or undefined. All right, so void in TypeScript represents the absence of not having a value at all. You often see it in functions that have no return value whatsoever. And if you create a function that has no return value, I might explicitly put the return value of this function is void just to make your code a little bit more clear. And then I probably wouldn't declare a variable with the annotation of void and say that it is of type void, because I think you can just use null or undefined for that case, since void types are only assignable to null and undefined. So hopefully this video gives you a good idea of how void works, and I will see you in that next. This video, you're going to learn everything you need to know about TypeScript Any and TypeScript Unknown, as well as the differences between the two and when you might want to use unknown and when you might want to use any. So first off, any is a special type in TypeScript that allows you to prevent type checking or type errors for a particular value. So when you use the any type, you can assign any value to whatever variable that you give that type of any to, and it will prevent type checking errors, and it will basically just make it like you're writing JavaScript. So here in this example on line 14, I have a let declaration, and I just have the label of X, and I give it the type annotation of type any. And here I assign it to the value of 12. But as you can see, I can assign this to any other value in JavaScript. I can assign it to a string. I can assign it to an array here. I get no errors because this is an any type. It is technically a top type in TypeScript, meaning that it is the broadest type that you can have, and you can fit any value into this type, and you can assign any value to it. And you can also assign an any type to any other type. So here, since my label of X or my variable X has the type of any, I can assign that to a type number. I could assign it to a string. I could assign it to a Boolean. It doesn't matter. You can assign an any type to any other type. And in general, it's probably a good idea to avoid using the any type as much as possible, as it basically takes you back to just vanilla JavaScript. And it removes the benefits of using TypeScript in the first place. And it removes that type safety. So in general, I would use the any type pretty sparingly. Now, it can be useful, as I mentioned here, when you are migrating a project over from just JavaScript over to TypeScript and you want to incrementally change that project from being JavaScript to TypeScript, then it's probably a good idea to use some any types and gradually have that changed over. And I think that it's a reasonable thing to use, and it's actually very useful to use in that situation. But for the most part, I would try to avoid using the any type as much as possible because you remove that type checking. Now, the unknown type, it is similar to any in the fact that you can assign any value to an unknown type. So just like any, I could assign a string, a number, a Boolean, any of those types I can assign to an unknown type. And like I say here, both of these types can be considered top types because they are the most broad types. You can fit any kind of value into these types, and you can assign any value to an unknown. However, unlike the any type, you can only assign an unknown type to either any or unknown. So here in this example, I have a label X here again, and I give it the type annotation of unknown. So it is an unknown type. And I assign a string to it, which is totally fine. I could assign any data type to an unknown, like I said earlier. It could be a number, it could be a Boolean, it doesn't matter. And then as you can see here on line 44, I can assign an unknown type, this X label, to an any type. And I can also assign this unknown type to another type of unknown. So I can do this as well. However, when I try to assign this unknown type to this type of number, I get an error. And it says type unknown is not assignable to type number, which kind of makes sense. if I am saying that this label or this variable here is of type number, but I don't know this type is unknown, then I can't assign it to a type of number because a number type is strictly for a number. It's not for types that you don't know the type of. But if I change this to an any, what you can see is that this does work, because in any type, that will fit the mold of any value, whether it's a number, a string, Boolean, so on and so forth. All right, so that is one difference between unknown and any. And I would say maybe the biggest difference is what we're about to talk about. And that is that you can't access an unknown type or perform certain operations on an unknown type unless you first do some sort of type narrowing. Rather than having your broad unknown type, you'll have to narrow that down to a more narrow type. So like a number, string, Boolean, before you can perform these operations. So let me keep my X label here, and I'm going to reassign it to unknown here. And then right here, I try to call x.toUppercase. And like, if I look at this, well, this is a string value here, and maybe this isn't as clear because it's the string of true, but let me just do hello here to make it more clear. But this is a string value here, which it has a toUppercase method, just like all strings in JavaScript, but I can't access this operation here. And that is because this is of type unknown. TypeScript is telling me that, hey, we don't know that this value here is going to have the toUppercase method because it is an unknown type. And this is exactly what this error gives me. Property toUppercase does not exist on type unknown. However, if I want to access a toUppercase method, well, that method is available on strings. So I need to make sure that this value is a string. And one way you can do this is you can use an if statement. So I can say if type of X, if my variable X here is of type string, then access toUppercase. And as you can see, this works because it knows that by the time I get to this line of code, this is going to be a string variable, and it's going to allow me to access the toUppercase method. So that is an example of narrowing your type so you can use these operations, because an unknown type, it's not going to let you access these operations until you do this. But if this was an any type and I just try to access this straight away, it's going to let me, because in any type, it's just like JavaScript. It's going to allow me to do any of these operations without first narrowing this type. All right. But let me switch this back to an unknown here. And what I want to show you is another way of narrowing your types. So you could also use a type assertion. And I generally would prefer an if statement over a type assertion, as you can kind of assert that a label is any type when you use a type assertion. And I think it's a little bit safer to use some sort of if check or conditional like this, but you could do something like this to where I have a variable here called upper and I assign it to my label of X, which is unknown. However, I use a type assertion here. I say as string. So for whatever reason, by this line of code, I'm telling TypeScript that, hey, I know that this is going to be a string right now. So I'm typecasting it to a string. And then I can access upper.toUppercase. But if I said number here, it wouldn't let me, because a number doesn't have a toUppercase method. All right, so you could also use type assertions here to narrow your types. But in general, I would prefer using an if statement, because like, as you can see right here, my label X, it's not a number here, it's actually a string, but I'm saying it's a number, which is incorrect. So you could have an incorrect assertion with here, but if you have this conditional right here, well, you're going to check with JavaScript that it is a string. Like, no matter what, there's no way that this isn't going to be a string when you get to this line of code. All right, so I like those a little bit better, but you could do something like the assertion here in certain circumstances. All right. So both any and unknown are top types in TypeScript that can represent any value. However, with unknown, you cannot assign an unknown type to any value. You can only assign an unknown to a type of any or unknown, whereas you can assign an any type to any value. And then to access properties and operations on an unknown type, you first need to type narrow with either a conditional or an assertion or something like that. And in general, I think that since unknown has these different kind of features to it, it does make it more type safe compared to just using any's in your program. So if you do need to use a top type like this, I would recommend trying to use an unknown first and then using some sort of type narrowing in your program to then use that unknown rather than just using the any type. All right. So hopefully this gives you a good understanding of any versus unknown in TypeScript, and I will see you in that next. Never type in TypeScript represents values that never occur. For example, if a function never returns a value or it just throws an error, then it's never going to return anything. So you could add a return type of type never for this function. Also, if in your program you have some conditionals and you are narrowing your different types down to no possible types, you might get type never. And every once in a while, you might see this in your programs if you find yourself writing some custom type aliases or you're getting data from a database and you're writing these conditionals to narrow a type, and then you just find that your value has a type of never. Well, if you see this, TypeScript is probably telling you that maybe something is off in your logic in which now you've narrowed your type so far that it actually can't be any type whatsoever. Now, with the never type, you can assign a never type to everything. So you can assign type never to anything in your program. However, you can't assign anything to a never type. So let me show you some examples of this. So here on line 19, I define a function called error, and it takes a message, and all it does is it throws a new error with that message. And a valid use of the never type here would be saying that this function has a return type of never, because it's never going to return a value. It always throws an error. An additional example of this would be if you had a function that just had an infinite loop and it didn't return anything. So in this function called infinite loop, it just has a while true loop and it just never returns anything. This would have a never type. Now, this particular example, the infinite loop, I don't see you ever writing anything like this in your program, but you might have a function that throws an error. And this might be an example where you use the never type, but I think it's more common to see this when you actually just have something wrong with your logic and TypeScript is like, hey, this value can't be any type. Are you sure you know what you're doing right now? And then you'll see the type annotation of never, and then you'll kind of know what's going on here. Now, you might see this example and you might be thinking to yourself, well, why wouldn't you just use void here? Because void is the absence of a return type for a function. Well, that is still a valid use here. You could use void, but one difference between never and void is that void can be assigned undefined and null, whereas never can't be assigned to any value like I said here earlier. So if we look at line 32, I say const x is type void and I assign it to undefined, and that is fine. And I could also use null here, and that would also work. But on line 34 here, I say const y is of type never, and I try to assign it to undefined. Well, I get an error. Undefined is not assignable to type never. And if I try null here, I'm going to get the same thing. I can't assign any value to type never. It literally represents a value that can never occur. So you can't assign any values to it. So that is the never type in TypeScript. You probably won't use this a bunch, but you occasionally might see it like TypeScript saying, hey, this value has type never. And that will give you an idea of, oh, I maybe have narrowed this too far to where I can't actually have a value for this, or there could be some sort of logic error or something like that. All right, so thanks for tuning into this, and I will see you in that next. Today's video, you're going to learn everything you need to know about the union type in TypeScript. We are first going to just give you an overview of what a union type is, then we're going to get into the syntax of a union type, and then talk about one tricky thing that occurs with unions that might cause you problems if you don't know about it. So we're going to make sure to cover that as well. So first off, a union type is a type that is formed from two or more types, and it will represent values that may be any of those types. So you might say that this value here is going to be of type string, or it's going to be of type number, or it's going to be an array. You're saying that that value is going to be one of several different types. So the syntax for this, I think this operator has a different name, but it's like the bar operator. It is the straight vertical line. And right here on line 18, I have a function called console ID, and it takes one argument here, an ID. And what I'm doing is I'm giving it a type annotation here, and I'm saying that it is going to be a number or it's going to be a string. So I'm using this bar operator to say this is going to be a number or it's going to be a string. So I must pass this console ID function an ID that's a number or a string. Now, you could do more here. I could also do like a number array or something like that as well, and that is still valid. Then I would need to pass this a number, string, or number array. Now, I would generally recommend not having type unions of like 3, 4, 5 different types, and I would probably create a type alias that represents that type at that point. Now, to create that type alias, you might say that this is going to be a number or a string or a number array and different things like that. But when you're just kind of inlining it here, I would probably create a custom type just to represent that in a bit more of a readable way and create a type alias for that. But I will cover type aliases here in future videos. All right, so the syntax here for the union types in TypeScript is you can use your annotation like normal with the colon, and then you can use the bars to separate some types to say that this value is going to be one of these types. And you can see that when I call this function with a number, that is totally valid. When I call it with a string, that is also valid. I get no errors. But if I call it with an object here, I get an error. And it says type of this object that has an ID of string is not assignable to a parameter of type string, number, or number array, because this is my type union of all of these different types here. So it's going to enforce that I must pass it either a number or a string. Now, one tricky thing with type unions is that to perform operations on a value within a union type, the operation must exist on all members of the union type, or you need to first narrow the type before performing those operations. So what I mean by this is that in my function here, my ID, it's going to be of type number or string. So if I wanted to perform an operation on my ID, well, that operation must exist on all members of this union. And what are the members of this union? Well, it's going to be a number or a string. Those are the two members. So right now, I can only perform operations on the ID that exist on both a number in JavaScript and on a string in JavaScript. So as you can see, if I try to do id.toUppercase, well, the toUppercase method is a method that only exists on strings within JavaScript. It does not exist on numbers. So I actually get an error here. I get an error saying property toUppercase does not exist on type string or number, because this operation, it only exists on strings. It doesn't exist on strings and numbers, both members of this type union. So I cannot do this. And to do this, I would first need to narrow my type. And the way that you could do this is with an if check. I could say if type of ID is equal to a string, then in that case, well, I know that this ID value is going to be a string. And I can just do my id.toUppercase without an error here. And you can see I don't get an error. And then in this else block, well, by the time I get to this else block, I know it's not a string. And if this ID has to be a number or a string, well, that means that I know that by the time it gets here, the ID is going to be a number, because I already checked whether it was a string or not. So here I could do some operation that only exists on numbers. So you can see I already get autocomplete of all the methods that exist on numbers. So I get toFixed, toPrecision, and different things like that. So I could do toFixed and do it to 1 digit or something like that. All right. So keep in mind that when you use a type union and then you want to use that value and perform some operation on that value, that operation must exist on all members of your type union. So in this case, my members are a number and a string. So if I didn't have any type narrowing, I could only use methods that exist on both numbers and strings. But if you do want to do some different methods that only exist on one of the members, you first need to narrow your type, which you can do by using an if condition, or you could potentially use a type assertion or something like that, asserting that it is a certain type. But I think that generally I prefer to do some condition like this. All right, so that is type unions within TypeScript. Hopefully this gives you a good idea on how they work and an understanding of how they work and how you can create them, and also makes you aware of kind of this tricky thing that some people can get a little bit confused with and really frustrated with TypeScript when they start getting errors like this. All right, so thanks for tuning into this, and I'll see you in that next one. You might have heard about this concept called type narrowing in TypeScript. And I know when I was first learning TypeScript, I really didn't know what anybody was talking about when they said, you have to narrow your types. But in today's video, we're going to discuss what type narrowing is through some examples and give you a good understanding, and also give you an understanding of why this is definitely a useful thing to know within TypeScript. So what is narrowing? Well, it's when you have a type that is a bit more broad. And what do I mean by more broad? Well, it's more than just a single type. It might be a type union in which a type is either a number, or it's a string, or it's a Boolean. And then with type narrowing, you're going to actually take this broader type and you're going to narrow it to a more specific type. So instead of a type being a number, string, or Boolean, you might narrow it to just a number. That would be considered type narrowing. Now, to narrow a type, you might use what is called a type guard, which will basically be some code that you will write that will say, okay, if the type of this variable is a number, then perform this operation. So you might add this type guard using the type of operator, which is what I just mentioned. You might use a discriminated union. We'll touch on those in a sec. You might use the instance of operator or different things like that. You add this type guard to narrow your type. Now, why do you even care about narrowing your types? Well, it removes something that a lot of TypeScript developers run into that is somewhat frustrating. And that is when you know that some value is going to be a certain type, but TypeScript still throws certain errors for you. So let's look at this example here. And we're going to use the type of operator to add a type guard in this example. So here I have a function called console ID. It takes one argument, and this argument is going to be of type number or string. And then I'm just going to console.log my ID, and then I try to call the toUpperCase method. Now, what's wrong with just trying to call this method on this value? Well, this ID here, I'm saying it's a number or a string. And numbers, they don't have a toUpperCase method on them. Only strings do. So TypeScript's going to tell me, hey, toUpperCase does not exist on type string or number. So what do I need to do here? I need to narrow my type to just a string so I can use my toUpperCase method. And how do I do that? Well, I can add a type guard. So right here, I can say if the type of my ID is equal to a string here, then at that point, TypeScript's going to know that my value is going to be type of string, and it's going to allow me to use this toUpperCase method here. Okay, so I add a type guard using the type of method to check if it's a string, and then that allows me to access the toUpperCase method because I have now narrowed the type of this value to just be a string. Now, I could also add an else statement here, and TypeScript will already know when I enter this else block, this value will most definitely be a number here. I don't need to say if type of value is a number. That is already inferred by TypeScript. Since I'm saying this ID can only be of type number or string, and I check here if it's a string, well, if it's not a string, then it's a number. So here I could access any methods or properties that exist on a number. So toFixed, toPrecision, value of, different things like that. All right, so that is one example of narrowing your types. So TypeScript will allow you to perform operations that exist just on that type. Now, if I wanted to perform an operation that exists both on a number type and a string type, you don't need to add a type guard. But TypeScript will enforce that you can only use properties and methods on any of the types that that value might be. And you can add type guards to narrow that type. Now, let me show you some more examples of how you might add some different type guards. So here you can use truthiness to your favor. So here I have the same function, console ID, but now my ID, I'm saying it can be either a string or null. So this value is potentially null. And TypeScript is going to tell me, hey, object is possibly null. So it's not going to let me just do to uppercase. So what I can do here is I can first check if my ID is truthy or not. So one way to do this would be I could say ID and do ID.toUppercase. And this and operator, well, if this is a falsy value, it's going to short circuit that and it's just going to return this value here. It's not going to evaluate to ID.toUppercase. But if this is a truthy value, then it is going to return ID.toUppercase. So this is one way you could do it. You could also use a ternary operator here. So you could do ID ? Then do ID.toUppercase. Else, just return the ID. You could also do an if statement here. You could say if ID, then ID.toLowercase, a method that exists on a string. So you can check for truthiness to add your type guards. Also, you can use the in operator. And the way that you can do this is, if you're not familiar with type aliases, no worries, I'll explain those in future videos. But here I have two just kind of custom types. That's what a type alias is. It's a custom type. And here I have an object that is going to have a swim method that just has no return value. And that is going to be my type fish. And then my type bird is going to have a fly method that also just returns nothing. So in my function here, I'm going to say that my function, it takes one argument, which is an animal. And it's either going to be a fish or it's going to be a bird. So how might I add a type guard here? Well, I can check if one of my methods exists within my object type here. So I'm checking, okay, does swim exist in animal? And if it does, then TypeScript knows that that must be a fish type, allowing me to call animal.swim. But if it doesn't evaluate to true in this if statement, TypeScript already knows that this must be a bird type, since animal is either fish or bird. So then I'm just going to call animal.fly. But I tried to put this animal.swim above my type guard here, you're going to see that I get an error because swim doesn't exist on both of these objects. I need to first check whether my method is in my object. And you can use that using the in operator. So if swim in animal, then you can do that. Else, if I ever get to this line of code, I know that my type is not a fish and it must be a bird, and I can access the fly method. Now you can also use the instance of operator to do a very similar thing here, to where here I have a function called log value. It takes one argument called x, and it's either going to be of type date, a JavaScript date, or it's going to be a string. And I check, okay, if x is an instance of a date, so it's a date instance. If that is true, then I want to call this date method. But if that is not true, then I know it's going to be a string, and then I just want to call x.toUppercase. So you can also use the instance of operator as a type guard to narrow your type so you can access these different properties and methods. Additionally, one method that you may have not heard about that is a little bit more specific to TypeScript is a discriminated union. So I don't necessarily love the naming of this, but I mean, it basically gets to doing what we've been doing this entire time. Narrowing your types so you can access a certain property or method without getting an error. So I have an interface called dog. And as you can see here, it's going to have a property of kind, which is just a string dog. And then it's going to have a property of man's best friend, which is true. And then it's going to have a speak function. And then here I'm going to have interface cat. It's going to have a kind that is cat. And then it's going to have a isChill property, which is true. And then a speak method as well. And then I'm going to create my own custom type, which is a pet. And it's either going to be a dog or a cat. And in my function right here, it's going to take one argument, an animal. And that is going to be of type pet. So my pet is going to be either a dog or a cat. And as you can see, when I try to call animal.speak, that works right away. I don't need to add a type check for that because the speak method exists both on my dog and my cat. So that's going to be totally fine to do. No matter what, this animal will have a speak method. But when I try to access animal.man'sbestfriend, I get an error because my cat object, it doesn't have a man's best friend property. So it's not going to let me access that because that does not exist on both dog and cat. So I need to add a type check. And what you might commonly see with a discriminated union is basically in a type interface, you might add a property called kind. And that is going to allow you to differentiate or discriminate between your different interfaces. So here I add this property to almost be like a unique ID for my dog interface. So my kind is dog. And you'll commonly see this written as kind or even type. And then on my cat, it's also written as kind, as cat. So here I can check if my animal.kind is equal to dog, well, then I can access man's best friend. Else I know it's a cat and I can access is chill. So by using this kind property here, I'm able to discriminate between my union of types here, my two different interfaces, allowing me to narrow my types to access these different properties and methods here. All right. And then also shout out to TypeScriptLang.org. They have a great page on narrowing that I definitely recommend you checking out for more information. But hopefully that gives you a good idea on just this concept of type narrowing, how it works, and how you can add these different type guards to solve different problems in your TypeScript program. So thanks for tuning in, and I'll see you in that next one. Type aliases in TypeScript. In today's video, you're going to learn what a type alias is, what the syntax of it looks like, and how you can create your own type aliases. And then we're going to talk about some key things that you need to know about how they don't just work for objects, optional properties, read-only properties, and also covering kind of how a type alias is just an alias. And TypeScript's not going to be able to differentiate between an alias and a different type. But if that doesn't make sense, we'll cover it here towards the end of this video. So first off, what is a type alias? Well, a type alias in TypeScript is effectively a custom type in which you create your own type based on kind of the primitive types in TypeScript, and you give it some label. So it's basically giving a label to your own custom type. And this allows you to have all the benefits of how it would be like using a variable in your program or using a label for some value. You can create this and then you can reuse it over and over again and prevent that code duplication. So the syntax of a type alias looks as follows. So here on line 12, I have a custom type here, which is a type alias called point. And the way that you can create your own custom type is by using the type keyword that's telling TypeScript I want to create a type alias here. And then following your type keyword, you can use the label for your custom type. So here I use point. And then you want to use the assignment operator. And I'm going to assign this custom type here to my label of point. So my type, it's actually going to be an object type here. So I open up a pair of curly braces and it's going to have two properties, X and Y. And both of those are going to be a number to represent my point type. And then the way that I would use this is just how I would use any other type in TypeScript. Here I have a function called print chord. It takes one argument here, PT, standing for point. And it is going to be of type point. So I give it the annotation of my custom type here. So I'm telling TypeScript, I expect this function to be passed one argument, point. And this argument is going to be an object with two properties, X and Y, and those are going to both be numbers. So I'm expecting to pass this function an object with X and Y properties, and then it's just going to console log those out here. So if I call this function, TypeScript is going to enforce that I call this function with the proper type here, an object with the properties of X and Y. You can see if I don't have these properties, I have a property called Z here, TypeScript's going to give me an error and it's going to say argument of type, this object with X and Z is not assignable to type point because point has properties of X and Y. So it's going to enforce those types here to my custom type alias. And then I could use this over and over again in my program anytime I want to represent some structure that has an X and Y property. Now, type aliases, you don't need to just use them for object types. You can use them for all sorts of different types in your program. So here I have a type ID and then I create a type union. This ID is going to be a number or a string. So I can use this ID type here if I want some value to represent a number or a string. And if you haven't seen my video on unions, that will help you understand more of what's going on here if you aren't familiar with what that is. So here on line 28, I have my ID and I give it the type of ID here. So it's got to be a number or a string. And here I assign it to the number 12. That is just fine. Here I assign it to a string, which is the string 12. That is also just fine because it can be a number or a string. But when I try to assign it to an array here, I get an error because my ID type is not assignable to an array here. All right, so you can use a type alias for any custom type that you want to create in your TypeScript programs. Now, one cool feature of type aliases is if you're creating object types with them and you want to create an object that has optional properties, then you can use a question mark operator. And this is going to allow you to tell TypeScript, hey, this property is going to be either of this type or undefined. You don't necessarily need to have this property on this object. So here, my custom type, paint options, it's going to have two properties, an X position and a Y position. And I put a question mark right behind the label X position before my type annotation here. And that's telling TypeScript that is effectively the same thing as doing this, that this X position is going to be a number or undefined. It's basically shorthand for doing that. All right. So that is an optional property, which means that TypeScript is not going to enforce that I have this X position on this paint options. It is an optional property. So if I have a function called paint options and it takes my options, and that is the type of my type alias here of paint options, and then I call this function, well, I can call it with just the X position alone because the Y position is an optional property. I can call it with just the Y position because the X position is an optional property, and then I can call it with both here. But if I tried to add a third property here like Z position and give that a value, it's going to give me an error because that does not exist on my type of paint numbers. And if I hover over this, you can see that my type annotation here, it gives you just what I kind of described. When you put the question mark before your kind of type annotation there, it's basically the same as doing a union between whatever that type is and undefined. So it's going to be that or undefined. And that is how you can use optional properties on your type aliases. Now you can also use read-only properties, and you can do that using the read-only keyword. So here on line 51, I create a type alias called someType, and then here before my property, I use the keyword read-only. So read-only prop is :string. So this property is going to be a string, but it's going to be read-only. And this doesn't mean that the value is necessarily immutable, but it does mean that you cannot reassign this property. So it's kind of similar to a const declaration for your variables. You can mutate an object within a const declaration, but you can't reassign it to a brand new object. And that's kind of the same thing here. If this was an object, I could change the values within that object, but I couldn't reassign it to an entirely different object because it's read only. All right, so there is a slight difference there between being immutable and read only. You can see here, if I have a function called do something and it takes an object that is my type of someType, you can see that I can access my property here and I can read it. But if I try to reassign my property here, I'm going to get an error and it's going to say, hey, cannot reassign to prop because it is a read-only property. So that is how you can create read-only properties within TypeScript. Now, one thing with type aliases that's important to remember is that an alias is just an alias. It's just a label for some type. And TypeScript is not going to be able to differentiate between an alias and an actual type. So if I create a custom type alias here called mynum and I assign it to a number, so I'm creating a custom type alias of a number, well, TypeScript's not going to know the difference between this type alias and just using a number type annotation. So if I create a variable called X and I give it the type annotation of mynum here, saying it's going to be this custom type alias, which is a number, well, I could still assign this mynum custom type alias to just a number type. So here I have a variable called Y and it is a number type and I assign it to X, which is my type alias of mynum. That is totally doable because TypeScript, it's going to say, hey, you have a variable called number, and you're assigning that to a number here. It's not going to care if you try to assign a type alias to a kind of more primitive type in TypeScript if they match structures. TypeScript's going to be okay with that. All right, so it's not going to be able to differentiate if something just has a label versus something that is kind of a primitive type built in TypeScript, and it's not a custom type alias. All right, so that is type aliases in TypeScript. In future videos, I'm going to cover type interfaces versus type aliases, and different stuff like that. So thanks for tuning into this, and I'll see you in that next one. Interfaces in TypeScript. In today's video, you're going to learn exactly what that is, how you can use optional properties on type interfaces, read-only properties, and then at the end, we're going to talk about some different things that we'll cover in future videos that are also important to know with type interfaces. So first off, what is a type interface? Well, a type interface is a way to declare a type for an object in TypeScript. It's kind of like the standard way that the TypeScript docs uses to create a type for their objects within their docs. So what is the syntax of a type interface? Well, it looks like this. So on line number 12 here, I create a type for a point object. And how you do this is you use the interface keyword. So this is a keyword in TypeScript in which it tells TypeScript, hey, I'm going to create a type interface here, or a type to represent an object. So use the interface keyword, and then following that, use the label for your type. So here, the custom type that I'm creating is called point. So this is going to represent an object, and I'm going to give it the type of point. All right. So instead of giving an object the type of number or the type of string, I'm going to create this interface and then give an object the annotation of type point. All right. And within this type interface here, you can see that I use no assignment operator. This is like the key syntactical difference that I always mix up between type interfaces and type aliases. With the type alias, you would use the assignment operator here to do $, and then your type. But with an interface, you don't. You just have the label here, and then following the label without a assignment operator, the $, you open up a pair of curly braces, and then you specify the properties of your object that you want to represent with that interface. So here, I want to represent two different properties, X and Y, and then I give them both a type. So X is going to be a number, Y is going to be a number. So I'm creating a custom type here, or an interface to represent an object, and I give the label of point, and it's going to have the properties of X and Y, and those are both going to be numbers. And the way that I can use this in my program here is, say I have a function called print coord for print coordinate. It takes one argument here, and I give this argument the type annotation of point. So I'm saying I'm going to pass it an object that is going to have all the properties and values of my interface here that is of type point. And all I'm going to do is I'm going to console log point.x and point.y, because I know that if I pass it a point type, it's going to have the properties of X and Y, and those are going to be numbers. But if I tried to console.log like point.z, well, I'm going to get an error because it knows that on my point type here, I don't have a property of z. All right, so it's going to enforce these types just like it would for any other type. All right, so that is kind of the basic syntax of an interface within TypeScript. Now, let's cover a couple of different cool things that you can do with interfaces. And this is by no means going to be all the things you can do with interfaces. This is going to be more of kind of the fundamentals of interfaces. And then in future videos, I'll have individual videos to cover more complex things with interfaces. But one thing that you can do is you can add optional properties to interfaces. So if you have a property on an object in which sometimes it's there, sometimes it's not, you might not necessarily need a value on that property. Well, you can use the question mark operator. And this basically tells TypeScript that, hey, this value here is either going to be of type number or it's going to be undefined. All right. So when you define your interface and you have a property, you can put a question mark right after that property before your colon, and that's going to tell TypeScript that this is going to be of type, whatever type you have, and then or undefined. And as you can see in this like code hint right here, it gives me that paintOptions.exposition is going to be number or undefined. All right. So giving it this question mark right here is almost the same thing as just doing this right here and saying it's going to be number or undefined. But this is kind of like the shorthand way of doing that. The way that this can be used is I have a function called paint shapes. It takes my paint options interface object as one argument here. And then when I call this function, you can see that I can call it with just my X position here because my Y position is optional. I can call it with just my Y position because my X position is optional. And then I can call it with both my X and Y position as they are both valid on this object. But if I try to do like Z position like this, I'm going to get an error because it doesn't exist on my paint options type. And then also you're going to see that if I remove this question mark right here on my Y position, you can see that when I first call this function with my options here, since I only call it with the X position, I get an error because this is now a mandatory field on this object and it's going to enforce that I must have it on it. But when I add the question mark here, it can be a number here or undefined. All right. Now you can also use read-only properties with interfaces. And the way that this looks is instead of using like the question mark after the property name, you can actually use the read-only keyword before the property name. So here I have an interface to describe an object and it's labeled some type and it's going to have one property. This property is going to be called prop. Not the most kind of unique naming convention there, but that is going to be a property on this object. And then to make this a read-only property, I can use the read-only keyword before the name of that property. And that makes it read-only. Now, one thing to remember here is that this doesn't necessarily make this property immutable. It just makes it so you can't reassign it. So it's similar to how const works in JavaScript. If you have an object here and you change some of the values within that object, that is totally fine. But if you try to reassign it to a totally different object, that is not allowed. So using this example here, I have a function called do something, and it takes an object that is of some type. And then here, as you can see, I can read this property or I can access this property when I use this console.log statement and I do object.prop. But if I try to reassign this prop to a different value, TypeScript's going to yell at me and it's going to say, hey, you cannot assign to prop because it is a read-only property, as this can be a way to kind of protect this property a little bit from having values that you don't expect. All right. Now, there's a lot of other things you can do with interfaces like index signatures, extending interfaces, and then having different intersection types with interfaces, but I'll cover those all in future videos. All right. So if you haven't seen my video on type aliases, I think this is very complementary to this one. So you can click that here on the screen right now. But if you've already seen that, there's a chance that these videos are already out. I would recommend going to those next, and I'll see you in that next. TypeScript Enums for beginners, plus a special bonus tier at the end. So first off, this video focuses on the fundamentals for beginners. There's definitely more things that you can do with enums, but this is going to give you kind of the basics about type enums. So what are they? Why are they useful? Well, type enums, they allow you to define a set of named constants. They make it easier to document intent within your program, and they can be used to create a set of distinct cases. So let's look at what this actually looks like and what the syntax of an enum is. So the way that you create an enum is using the enum keyword here in TypeScript, and then you use some label for your enum. And then you do not use an assignment operator here like so. You do not use an equal sign. All you do is open up a pair of curly braces here. And then what you can do within the curly braces is have certain labels and then separate those labels by commas. And what TypeScript is going to do here is it's going to, by default, assign all of these values to a number. And it's going to start with 0, and then it's going to auto increment that number for every label. So up is going to be assigned to the value of 0, which you can see it is in my type annotation here from VS Code. And then down is going to get the type annotation of 1. Left is going to get the annotation of 2. And then right is going to get 3. So up's assigned to the value of 0, down 1, left 2, then right is 3. And if I console log my enum here, you're going to see that I do get all of these values for the corresponding labels. All right. So TypeScript's automatically going to give these some distinct values. Now, you can also override that default behavior and give your own values to a type enum. So if I scroll down here, on line 37, I create the very same enum. I use the enum keyword, then the label direction, that's the label of my enum. And then I first have this value of up, but I assign it to the value of 5. So the way that you can assign a value to an enum is using the assignment operator after your label here. All right, so it's not a colon like you would with an object. Instead of the colon, it is an equal sign. And what TypeScript's going to do here is for all these other values here, down, left, and right, that I don't give a explicit value to, TypeScript is going to automatically give these a value starting from the value of 5 here. So down is going to get the value of 6, left is going to get the value of 7, right is going to get the value of 8. Because since I give it the default value of 5, it's going to auto increment the rest of these to give them a distinct value. And this is why enums can be used to define a set of named constants and kind of document some more intent, because you know all of these are going to be unique values, and enums are particularly useful here when you don't really care about the value itself. Like, I don't necessarily care that this direction.up is the value of 0. I just care that it is distinct. And I'll show you an example of using these here in just a second. But if I change this to the value of 8 here, you're going to see that now down is going to get 9, left is going to get 10, right is going to get 11. So whatever value you give it here as a number, it's going to auto increment those for the rest of those values to make sure that all of the values are indeed distinct. All right. And this is particularly useful when you maybe don't care about the values themselves as much and you just need like some label to make a distinct set of values. So let me show you maybe a little bit more of a real world use case of how this would work. So on line 51, I define an enum called user response, and I give it 2 values, no and yes. So these are going to be 2 distinct labels that I can use. And then here I have a function on line 56 called respond. And it takes a recipient, someone I'm sending a message to, and then the message itself. And it is of type enum, the message is. And it's either going to be no or yes. And in the body of this function, well, I can say if my message is equal to yes, return the recipient said yes. But if that's not true, then return the recipient said no. So here I use this enum. It doesn't really matter what values are assigned to no and yes here. It's just giving me kind of a user readable way to use these constants. User response.yes. That's pretty obvious what I'm doing there. I don't really care what value is in user response.yes. I just care that this is readable and it's a unique constant here. So when I call this respond function, I pass it the recipient of dude, and then I pass user response.yes. So it's going to enter the body of this function. Message is going to equal user response.yes. So it's going to return recipient said yes. So if I run this code here, what you see is dude said yes. And then if I change this to no, you're going to get dude said no. All right, so I don't really care about the values themselves here. I just want it to be a more readable, descriptive way of using these. All right. Now, you can also use string enums as well. They don't necessarily have to be numbers. TypeScript supports them both. So this would also be a totally valid way to do this. You could create your enum here like I do here, and then you could assign your label to a string value. This would also be a valid enum. Now, one thing I want to mention with enums is that an enum really wouldn't be much different than doing something like this, creating an object and then just having those values in the object work as your constant. So if you use as const in TypeScript, it's going to make it so that this will remain a constant, and I'm not going to be able to mutate these values here, which makes this like a true constant and gives me certainty that these values are going to stay the same. So really, an enum's not going to be much different than creating an object here and then creating it as a const. And this would actually be my preference when using constants in my program, because this This is what most people who write JavaScript code anyways are going to be more familiar with, as their constant's just an object opposed to using enums. It's not all developers are really going to know what that is, and it's kind of more TypeScript specific there. So I would probably still go this route, but enums are still good to know because if you're in a TypeScript code base, there's a decent chance you're going to see them. And like at first glance, it could be tricky to kind of know what they're used for and to know that all these get a default value of 0 and then they auto increment. That is just because we don't really care as much about the value. They're just supposed to kind of be readable, descriptive ways of using these constants in your program. All right. But for a special bonus here, how did the programmer die in the shower? He read the shampoo bottle instructions, lather, rinse, and repeat. And this was like a dad joke for programmers. Type assertions in TypeScript and why they are even useful. So sometimes in TypeScript, you'll have a value in which TypeScript isn't going to be able to know the type of that value. So for example, if you use the document.getElementById method, or you get an element from the DOM, TypeScript, it will know that that element is going to be an HTML element, but it's not going to know the specific type of HTML element. For example, it's not going to know if it's an HTML input element or a list item element or different types of elements. And in these cases, you can use a type assertion to basically tell TypeScript, okay, I know that this is going to be an input type or some other type. And you assert that this will be this type, and TypeScript is just going to trust that type assertion and behave as if that value is that type, okay? So a type assertion allows you to explicitly say that some value is going to be some type, and then TypeScript is going to behave and provide type safety around that specific type, all right? So let me show you what this would look like. And this can also be thought of as narrowing to a more specific type. So if you get an HTML element from the DOM, the general type is just a general HTML element, but a more specific type would be a HTML input type. So you can use these assertions to kind of narrow your types a bit, which I'll show you why that's useful here right now. So in this example, I use the document.getElementById method here. So document.getElementById, and then I get an element, and then I can use my type assertion here using the as keyword. So following my document.getElementById call here, I can follow that with as HTML input element. And this is telling TypeScript, hey, this element that I receive back from the DOM here, it is going to be a HTML input element. And the reason this is useful is because, for example, right here in input element, it has a value property. You can access the value property on input elements. And TypeScript, it's going to be okay with me doing this here because it knows that this is an input element and has a value property. But what if I remove my type assertion here? Well, now I get an error. And the reason I get this error is because this is an HTML element now. It is a general HTML element. And not every HTML element is going to have a value property. And because of this, TypeScript is like, hey, you can't access this value property. It doesn't exist on all HTML elements. You effectively need to first narrow this type, make it more specific before we can access this value property. So one way to do this here is using the as keyword to make a type assertion and then saying it is a specific type of input element and seeing this error go away. Now, there is an alternative syntax to using type assertions within your program. So here you could do the same thing, but before your call to document.getElementById, you can use kind of the generic syntax in TypeScript in which you can use a left angle bracket and then specify the type of the element. So here I could put HTML input element here like I did earlier. And this is going to tell TypeScript that this value here is going to be an input element, and then it's still going to allow me to access the value property on it because it is an input element. But if I change this to a different type of input element that might not have a value property, let's go the marquee element, we're going to get an error. So value does not exist on that element. All right. So you can use this alternative syntax here to make your type assertions to tell TypeScript the type of some value more explicitly. All right. Now, one thing that is kind of important to note here is that TypeScript is only going to allow type assertions to occur when you are going from a more general type to a more specific type, or if you're going from a more specific type to a less specific type. It can't be a completely different version of a type. And this helps prevent impossible type coercion. So here in this example on line 37, you're going to see that this doesn't work. I am assigning a value X to a string here, hello, but I'm trying to assert it as a number. And these are two completely different versions of a type. You have a type of number and a type of string. TypeScript's not going to allow this assertion to take place. And it's going to give me this error, conversion of type string to a type number, maybe a mistake because they basically have no overlap with each other. They are different versions of types. But earlier, we could use this assertion right here without an error because I'm going from an HTML element type to an HTML input element. They are the same version of a type. I'm just narrowing it here a little bit more. And I could alternatively, if I had an HTML input element, I could generalize it a little bit more to an HTML element. Now, I talked about type narrowing a bit here, and if you want to see a full video on that, make sure to click the video on the screen here, and I will see you over there. Generics in TypeScript. What are they? How do they work? What does the syntax look like? Why are they useful? All those questions will be answered in this video. So first off, there's definitely going to be more advanced things that you can do with generics that I won't cover in this video, but this will give you a good fundamental understanding of how they work and will allow you to start using them within your program. So what are generics? Well, a generic allows you to add variables to your types. And the reason that this is useful is because it allows the type system to be a bit more dynamic and a bit more generalized. So you can use these generics to make a more generic type or a more generalized type and allow a bit more reusability throughout your program, but still have plenty of type safety. So let's go into how these actually work. So one thing you might be thinking is like, okay, if I want a more general type, why don't I just use the any type or some other top type like this? Well, the main reason for this is because when you use the type of any, you really don't have any type safety. So here I have a function called identity. I set the argument to type any and the return value of type any. And you can see that I call this with a number here on line 28, but then I try to access the toUpperCase method on this number. That's an error. And when you use the any type, it's not going to catch this. But good thing, we have generics that we can write this function in a general way, but still have our type safety. So that's what I do right here on line 34. So this is where I start to use my generics here. So here, when I want to create a function that uses generics, allowing me to pass variables in for my types here, I create my function, I give it the label, and then following the label of your function, you can open up a pair of left and right arrow brackets. And a common convention here is to use the label of uppercase T, and it stands for type. And effectively what this means is that when I call this function here, I'm going to pass a type to this function, and then I'm going to use that type throughout my function. So here, after the label of the function, you can open up a left and right arrow bracket, and this is going to be your generic type. And then I can pass a type to this function, and then as you can see, I set my argument to whatever type that I pass into my function here, and then I also set the return value of my function to whatever type I pass into my function here. So you can see how this might be useful because when I call this function, I could call it with a number or a string or a Boolean, and it's going to set my argument to either a number, string, Boolean, whatever I pass in, and it's also going to have me return that same type. So here, when I call this function on line 39, I can pass in my type, by when I invoke my function, right following the function label, I can open up a pair of left and right arrow brackets, just like I did when I defined my function here. You kind of match the overall structure here when you call the function, and I can pass in my type. So I pass in the type string. So when I call my identity function, I pass in a string as this variable right here that assigns my argument to type string and my return value to type string. And as you can see, everything works here. This constant here, well, it's of type string because that is what I pass in here, and that is what's assigned to my return value. And it allows me to access my string.toUpperCase method. Now, what if I pass in a number here? Well, it's going to throw errors because it's saying, hey, argument of type string is not assignable to type number, because I'm still trying to pass a string here when I'm telling TypeScript my argument is going to be a number here because I pass my number as my generic type, and then my argument is assigned to that generic type. Same thing with my return value. And then also doesn't allow me to access this toUpperCase method because the return value should be of type number because that's what I pass here. But if I switch this to just the number 1, then it's okay for me to call it with a number 1, but I can't access the toUpperCase method because it's still a number. But I think I could do like toFixed here, and that's going to be just fine because it expects a number. Now, you don't always need to explicitly pass your type like this with a left and right arrow brackets. And if I remove this, you see that it still works because TypeScript still uses its type inference system to infer that, okay, if I'm calling this with a number here, then the type that I'm passing to this function, it must be a number. So you can still use inference here, but sometimes I do like to explicitly say, hey, I want to pass a number to this function in this instance. But then I could call this function several other times, and I could pass a string to this function. We'll just change the name there, and you can see that I can call this function several different times and just pass different types to it, and it allows this function to be more generic because I use generics within this function. Now, one thing to note when using generics is that you might need to use a little bit more type narrowing within a generic function. So what do I mean by this? Well, here on line 45, I have my very same identity function here. What you see is that within my function, I try to access my argument.length property, but I get an error. It's saying property length does not exist on type T. And that is because since I can pass any type to this function, TypeScript's like, hey, this .length property, it doesn't exist on every potential type that you might be able to pass to this function. So within the body of this function, the way that I can correct for this is I can add a type guard here, and I can narrow this type, and I could use the array.isArray method, pass in my argument, and then I'm saying, okay, well, if it's an array, then I can check the .length property, but only if it's an array. And that's going to be okay because I've narrowed this type to just potentially being an array. All right, so when you use generics, since they are more generalized, you might need to use a little bit more kind of type narrowing and type guards when kind of defining your generic functions. Now, you're not just limited to using generics with functions, and you can actually use generics when writing an interface as well. So here, I'm going to create an interface, but I'm going to use a generic interface. So here, I'm going to create my interface, and I'm just going to call it generic value because I am very creative with my naming conventions. And just like how behind the function label, you open up a pair of left and right brackets and then give that kind of your variable for your type, you do the same thing with interfaces here. I can open up left and right brackets, and then I can open up my interface, and now I can use this type within my interface. So let's just say that I have a value property, and it's going to be of type T. All right, so I can pass a type to my interface here, and that is going to assign the type of this value property to whatever type I pass into my interface. So if I want to use this now, I can say const value that is going to be of my generic value. Well, I can do the same thing I did before. I can call this with some type. And here I'll call it with a number. Now, when I assign this to a value here, well, I'm going to need to assign it to an object that has a value property that is of type and number, because that is what I pass as my generic type. So here I'll do value as 1, and TypeScript is all happy with this because I pass in a number type here. So it expects me to have an object here that has one property that is value, and it has a number type. And that is exactly what I do here. But if I change this to a string, it's not going to be happy because it's saying string is not assignable of type number because I pass a number as my type here. So it gives my value a type of number. So this is not valid. But if I were to pass a string here, that's totally fine, and that works. Because value is now expected to be a string because I pass it as a string right here to my generic type and assign the value to of type string. All right, so hopefully this gives you a good example of how these generics allow you to create more generic types and more reusable types within your programs. And you can use them for functions, interfaces, types, and different things like that throughout your programs. Hopefully that gives you a good fundamental understanding of how generics work. Now, some people get a little bit confused with the type narrowing that I did earlier. If that is you, make sure to click the video on the screen here. But if not, I will see you in that next one.